Okay, moving on. We're at a concession stand now. They're selling hamburgers and hot dogs. You know what we got to do? We got to start at the beginning and read and see what info we got. At a concession stand, 7 hot dogs and 4 hamburgers cost $14.75. So I'm going to stop right there a second. Okay? When we read this story through the first time, it sounded like there were 2 trips they made to the concession stand, right? And both times they bought hot dogs and hamburgers. Agreed? Okay. So, hot dogs and hamburgers. And it sounds like on the first trip, right? They bought 7 hot dogs and 4 hamburgers. Now, their cost, right? So this one's a little bit different, but their total cost, okay, not the amount they bought, but the total cost for this many of each was $14.75, wasn't it? Okay. But then they made a second trip to the concession stand. And on the second trip, they bought 4 hot dogs and they bought 7 hamburgers. And on that trip, the total cost was $15.50. And they want to know the cost of each. Well, cost per item. Do we know the cost of each item? Certainly don't. I just know that when they bought this many on the first trip, that's what they paid, and on the second trip, this is what they paid. Do I know the cost of for the hot dogs? No. I'm going to call it D. D for dogs. Do I know the cost of the hamburgers? Nope. What do you think I'm calling it? Good. B for burgers. Now, here's the deal. How many variables? Good, 2, which means you need how many equations? Good, 2. Notice I have 2 totals, don't I? That's going to dictate my 2 equations. With me? So I know one equation is going to have a total cost of $14.75, right? Okay, now remember how you get a cost. We did that in the last problem with the frames. And I even sidetracked you with the grapes and the apples, didn't I? And if you don't remember it, we'll rewind the video and go back and look. So here's the deal. On this first trip, they bought 7 hot dogs at this cost, right? Good. So you got to do the amount that they bought times the cost. And add to it the number of hamburgers they bought times the cost. Make sense? Good. All right, well, I used that total. It's done. But I have a second total of $15.50. And same thing, right? So 4 hot dogs at this cost. And add to it the number of these hamburgers at that cost. And I used that total. And looks like I came up with my 2 equations and 2 unknowns. Well, the 2 unknowns we have, but at least I came up with the 2 equations. So what method do you want to use? Yeah, I'm going to use elimination on this one. I'm not even going to try substitution. Because if I try substitution, I'm going to end up with fractions because I got to divide by a 7 or a 4 somewhere, and that's not going to work out evenly. So the question is, which variable do you want to eliminate? All right, let's just go for the D's. So that means I need the coefficients to be the same number and the signs opposite. So basically kind of a common denominator between a 7 and a 4. Yeah, 28, which means the first D needs to get multiplied by 4, and hence the entire equation, right? And the second one by 7. But that'll keep them both positive. I need one to be negative. All right, we'll do the first one as negative. It doesn't really matter, right? Because it's going to work out the same. So, yes, I'm getting my calculator ready. I know you guys have yours right there at your fingertips. First equation multiplied by 7 gives me a negative 28D minus 16B equals a negative, okay, so what's $14.75 times 4? Good, a negative 59. Second equation is being multiplied by a positive 7. So that's 28D plus 60, look at me. See? So I need you guys doing the work with me. 7 times 7 is 49. 49B equals, now I gotta do 1550 times that 7, right? I end up with $108.50. Do you? Okay. And now we get to add. Well, the D's drop, which is what we wanted to happen. Agreed? And so now a negative 16 and a positive 49. Good. That looks like a, right? Positive 33B. Good. Equals, and I ended up with 49.50 over here. Did you? Good. And then, yep, divide both sides by B, and I got 1.5. Okay, we just found the value for B, and now you got to find the value for D. So what are you going to do to find the value for D? Yeah, plug the B in. I don't care which equation. You know what, I'm just going to plug it into the second one here. Why? Because it's just a little easier to access for me, that's all. Okay, so 4D plus 7 times 1.5 equals 1550, right? So 4D plus, okay, what's 7 times 1.5? 10.5 equals 15.50. Then subtract the 10.5 to both sides. I'm with you. Okay? What'd you get? 5, right? And then divide both sides by 4. And I got 1.25. Did you? Okay, so now let's check it out. What do these answers mean? Well, they stood for the cost of each item, didn't they? So, D is 1.25. So that tells me the cost of the hot dogs is $1.25 each. And B was 1.5. Well, that tells me the cost of the hamburgers are $1.50 each. Does that make sense? Awesome. Hang in there. Okay, so on this next problem, when you read it, what came to mind? Yeah, you're talking about a plane, right? And it's traveling with the wind and against the wind, right? And we've dealt with a problem like this before, did we not? Okay, so let's go through it up until each punctuation mark and see what information it's telling us. It said the plane traveled 460 miles per hour with the wind and 400 miles per hour against the wind, right? Okay, so what are we talking about? A plane traveling with the wind and against the wind. Okay, so and plane against wind. All right. And the 460 miles per hour, what does that represent? Yeah, that represents how fast the plane is going, right? That's the speed of the plane, isn't it? Okay, so with the wind, it's 460 miles per hour, right? Oh, and by the way, that's in miles per hour, isn't it? And against the wind, it's 400 miles per hour, isn't it? Okay. And they want to know the speed of the plane in still air, which means there's no movement, right? None. And they want to know the speed of the wind. Do you know the speed of either one of them? Nope, neither do I. So, over here, I'm just going to write my notes to myself because this Doesn't look like it matches up too nicely. So speed of plane in still air. I don't know it, so I'm just going to call it P if you're okay with it, but I do know it's in miles per hour. And then they want the speed of the wind. This is also going to be in miles per hour, but I don't know it, so I'm going to call it W. With me? Okay, so I've got two variables, don't I? Which means I need how many equations? I need two. Okay, so remember what we've done with the last couple of problems. Those totals usually tell us the two equations, don't they? So I've got a total speed of 460 miles per hour, don't I? But that total speed is with the wind, isn't it? So now let's think about this. I'm going to sidetrack you a second. Remember when you were a kid and you're riding your bicycle? And let's say you're able to pedal at 5 miles per hour. And all of a sudden there was this nice wind that came up from behind you and helped push you along, right? And let's say the wind was traveling at 2 miles an hour. So you're going at 5 miles per hour and the wind is going with you at 2 miles per hour. Were you still really traveling at 5 miles per hour? Good, you weren't. You're traveling how fast? 7. Because you took your speed and added the wind's because it came up from behind you and now the wind was going with you, right? Well, the plane is going with the wind. So, do you think I'm going to treat it any differently than you riding your bike and the wind coming up behind you and getting 7 miles per hour because you added? Nope, no different. I am going to take the speed of the plane and I'm going to add to it the speed of the wind, and that's going to give me that 460 miles per hour that plane is traveling. Cool? Okay, the other total was 400 mile per hour speed, wasn't it? Now, but this one's against, right? The plane's going against the wind. So, is the wind helping the plane, or is the wind kind of like hindering it, like pushing it back a little bit? Yeah, it's hindering it. That's like when you were a kid riding your bike and the wind comes against you, it's like, okay, I gotta pedal harder, right? You're not going as fast as you were. So what operation would you do? Yes, you would subtract. Now be careful of the order in that you subtract. Who's supposed to be faster? Who has the faster speed, the plane or the wind? Yeah, the plane better be faster than the wind. That's all I gotta say. Because if the wind is faster than the plane, that plane is in deep trouble. That's all I gotta tell you. So in this case, we're going to take the speed of the plane and subtract the speed of the wind. Does that make sense? Awesome. Well, there are my two equations because I had two unknowns. Which method is this best for? Yeah, I could solve by substitution, but I'm going to use elimination because I'm noticing the W's have the same number in front and they're opposite signs. So I'm just going to use elimination. And I'll get 2p equals 860, and when I divide by 2, because those guys dropped, I get 430 for P. Does that make sense? Okay, still need to find W, don't I? Because I also want to know the speed of the wind. So, doesn't matter which one you take. I'm just going to use the P plus W equals 460. And now that I know P is 430, right? Substitute it in. Subtract. Looks like the wind is at 30. So, plane. Your plane is traveling at 430 miles per hour. Your wind is traveling at 30 miles per hour. If you add the two, you'll get the 460. If you subtract them, you get the 400. So we are good to go here, right? Now, some of you may first have looked at this problem as a distance problem. The challenge was, it didn't say anything about how far they traveled. And it didn't say anything about how long it took them to travel. All it talked about was the speed. That's it. Just the speed. Got it? Hang in there. Got one of those distance problems. Okay, so now we read the next problem, and that's one of those distance problems, because not only was it talking about the speed, but it was talking about how far they traveled and how long they traveled for, correct? Okay, so when you read it, as I suggest with all of these distance problems, how many trips are they taking? 2 trips. We've got the trip going and the return trip, don't we? So we got the outbound trip and the return trip, right? So whatever you want to call it. But they specifically said the return trip. So I am definitely going to be using that statement. So we have got, how about we just call it the first trip? And then we have the return trip. And we know this is what kind of problem? Distance. So what should we write? Yep, just like we have done before. D equals R times T. Cool? Okay, let's go pick this story apart, see what information we got. It says an airplane takes 3 hours to travel a distance of 1,560 miles with the wind. Okay, so there's that with the wind thing again, right? So the first trip is with wind. And they told us that this plane took 3 hours, so that is your time. So 3, and it's in hours. And they traveled a distance of 1,560 miles. So this is in miles. And it was 1,560, correct? And that was with the wind. All right. Any other information in that first part? Nope. So pick it up from that punctuation to the second one. The return trip takes 4 hours against the wind, right? All right, so now this one is against the wind. And it took 4 hours. That's what they told us. And that's all they said there, right? Okay, but you know, there's actually another piece of information that I can write down. Based upon the fact that it's the return trip, what other piece of information can you tell me that they didn't? And some of you are going, I'm not sure. So let's think about this. So when you go to school, right? From home to school, however long it takes you, right? Or however miles you travel. Well, if you know, like from school, when you're done with classes, you're going from school straight home, that's the return trip, isn't it? So the trip to school, say, was 10 miles, and the trip from home, from school back to home was also 10 miles because it's the return trip. So the number of miles is the same from home to school and back again, right? Okay, so even though they didn't tell me, the return trip is also a distance of 1,560 miles, isn't it? Okay, got it. And the last part says, find the speed of the plane in still air and the speed of the wind. Boy, that sounds familiar, doesn't it? Yeah, it kind of sounds like the last problem. Agreed? So, let's write this down then. We've got speed of plane. Whoops. In still air, and it's in miles per hour. I don't know, and I'm going to call it P if you're okay with it. And then the speed of the wind, also in miles per hour, and I'm going to call it W. Looks very familiar, right? Looks like the last problem, doesn't it? And it's talking about the speed, which is R. R is rate. It's also in speed, isn't it? And that's in miles per hour. Now that we see this, Well, the first trip is with the wind. So what would I do to get the actual speed of this plane? Yeah, good. You're going to do the plane plus the wind. And the return trip was against the wind. So, good. The speed of the plane minus the wind. Agreed? Okay. And now, how many variables? 2. How many equations? 2. And the formula tells you how to set it up, doesn't it? D equals R times T. One equation is going to represent that first trip. The second equation is going to represent the return trip. So let's take a look. So my first trip is 1,560 equals, good, 3 times P plus W. My return trip is 1,560 equals 4 times P plus W. Does this make sense? Okay, now there's a couple of different ways you can actually solve it from here. You can distribute the 3 and distribute the 4. Me personally, I'm going to see if 1560 divides by 3 evenly. Did you figure it out? Go ahead, I'll wait. It does, doesn't it? I can divide both sides in this equation by 3. It'll drop that 3 out, which will give me, 520 equals P plus W. And I'm going to see if both sides divide nicely by 4 on the second one. Because if they do, my equation is looking a whole lot nicer. Does it? Yeah, it was 390. Agreed? Equals P minus W. Well, this is looking really familiar, just like the last problem, isn't it? Okay, so let's work with it. Add these together, because the W's drop, don't they? Divide both sides by 2. Yes? So P equals 455. Got it. I still need to find W. So, plug it into either equation. It doesn't really matter. So we've got, I'm just going to use the 520 equals the P, which is 455 plus W, and subtract from both sides. And I end up with, I got 65. Did you get 65? Yes? Okay, got it. So, what's P represent? P represents the speed of the plane in still air. So, that would be 455 miles per hour. And then the speed of the wind, which is also 60, well, not also, but it's 65 miles per hour, isn't it? That's a pretty strong wind. But we did everything correctly, right? Divided both sides. We did everything correctly. So be it. Good? So this problem incorporated the last problem. The last problem just talked about the speed. This problem incorporated that speed with and against the wind in the distance problem itself. Cool? All right, hang in there. I'll be right back with another one. Okay, so the next problem is talking about car rental agencies, isn't it? And how many car rental agencies is it speaking about? It's speaking about 2 of them. And what are their names? Ultimo and Primo. All right, so let's write those down. Car rental agency. That's my shorthand, CRA. And then we have the Primo car rental agency. Got it? Okay, let's start at the beginning and see what info it's giving us. Primo car rental agency charges $20 per day plus 30 cents per mile. Okay, so I see a daily charge, and our Primo, right, car rental agency is $20 a day and 30 cents per mile. So I see a per mile charge, which is also in dollars, and this was 30 cents per mile. Got it. Ultimo car rental agency charges $20 per day. Oh, it looks like the same. And 95 cents a mile. Ooh, they're more expensive. Well, clearly right off the bat we would know which car rental agency we would go with, right? Okay. Find the daily mileage for which the Ultimo charge is 3 times the Primo charge. Okay, so first off, what do they want to know? They want to know the number of miles. Do I know the number of miles? Nope, we're going to call it M. Okay, so number of miles, M. Okay, but now the other part of the last line is interesting. For which Ultimo charge, okay, so let me write this down. Ultimo charge, sounds like a cost, right? Is, that means equals 3 times the Primo charge, right? Okay. So if I know how to figure out how Ultimo is going to charge us and how Primo is going to charge us, then I can just plug them in, can't I? All right. So here's the deal. How do I figure out Ultimo's charge? How do I figure out the charge? You're going to go rent a car at Ultimo, and they're going to tell you, well, it's $20 a day and 95 cents a mile, right? So for one day, yeah, you're going to do $20 and you're going to add to it because they're going to charge you 20 bucks right off the bat. And then they're going to charge you what? Well, 95 cents a mile. So how do I figure out that? Good. 95 cents times the number of miles I drive, right? Okay. How do I figure out Primo's charge? Yep, they're going to charge me 20 bucks off the bat and then 30 cents a mile. So 30 times the number of miles, right? Okay. This equation that we half wrote in English and half wrote in math is coming alive. So Ultimo's charge, 20 plus 0.95 m equals 3 times Primo's charge, 20 plus 0.30 m. Are you with me? Okay. I don't know why they would want to know this, but so be it. So let's start doing our solving. I'm going to have to multiply the right side. I'm going to have to distribute that 3, correct? So when I just, whoops, that's an addition sign. Sorry, guys. And then I have to collect the m's on the same side. So I'm going to bring the 0.90 to the left. Why? Because I want to keep my m's positive, right? The coefficient in front of m positive. And then I am going to move the 20 to the other side. And, yep, I am going to have to do 40 divided by the 0.05, aren't I? I don't know about you, but I got 800 miles. They're going to have to drive 800 miles in order for the Ultimo charge to be 3 times the Primo charge. Cool? Not too bad, right? Yeah, the key is knowing how to figure out the cost per day, really, if you think about it, of Ultimo and Primo. $20 plus however many miles they drive, right? All right, I'll be right back. Got another one for us. Okay, so this next problem has this figure in it. And they tell me M and N are parallel lines. And this line that's cutting through M and N is a very specific line known as a transverse axis. Why is it called that? Because it is cutting through these two parallel lines. So it has a very specific name. Now, back to geometry days, you're going to have to remember something about this. Okay? Because this setup is back to those alternate interior angles, alternate exterior angles, all that other stuff. And you may or may not remember that. Okay, so I'm going to walk us through something here. So here's something I want to show us right off the bat. Do you notice right here this X and this Y? They are two angles and they are forming this straight angle, which is also known as a line. Which means if I add these two angles together, I'm going to get 180 degrees. Because technically that's the angle of a line. Because it's half of a circle, 180 degrees. Are you with me? Okay. By the way, I should have backed up. 2 variables means how many equations? 2. Well, I got one of them. And one of them is x plus y equals 180 degrees. Got it? Okay, now, the other one is, this one may have been obvious to some of you and maybe not so obvious to others. But this next one, you really have to kind of remember your geometry days. The next one is banking on alternate interior angles. And the reason I say that is this. This angle right here, which is representing x or y minus 48, and this angle right here have the exact same measurement because they are alternate interior angles, which means this x is equal to y minus 48. That is back from your geometry days of alternate interior angles. Got it? Okay, yeah, a little bit of refreshing needed on this stuff, right? Okay, so, and by the way, x plus y here were known as supplementary angles, if you remember that word from geometry days. All right, so now I have 2 equations, don't I? Now it's time to solve. So, this one looks like it's set up for which method? Yeah, this one looks like it's already set up for substitution, doesn't it? Because the second one told me x equals this. So in the first equation, instead of writing x, couldn't I write y minus 48? And then plus the y equals 180? Yep, I can. Collecting like terms, correct? Moving the 48 over, right? And dividing by 2. Yes or no? Good. So I end up with y being 114. And now I got to find x. Well, they told us x equaled y minus 48, so x must equal 114 minus 48, which means x equals... that's wrong. What'd you guys get? Because I've got this off. No, not going to tell me? Fine. Then I'm going to figure this out. There we go. Sorry. That's what happens when my brain moves too quickly sometimes. It wants to put the larger number on top but not keep them together. That's not smart. Okay, there we go. Good? Okay, so X is 66 degrees and Y is 114 degrees. And again, this was all based on you remembering alternate interior angles, recognizing these two are supplementary angles, and then setting up the equations. Cool? Hang in there. Got another one for us. Okay, so the next problem gave us two functions to work with. They gave us a cost function and a revenue function. With me? And they're asking us to find the number of units, which is known as X, that must be sold to break even. All right, so let me back up a second, because they already gave these two functions to you, which was very nice of them, but it would be really good to understand where they come from. So first off, X is the number of units, right? Okay. Let me make sure you understand revenue. That's what R is supposed to stand for, is revenue. Revenue is how much money is coming into the cash register that day. With me? Or that month or that year or whatever they're talking about. But that's the amount of money in the cash register. X is the number of units. Now, let me sidetrack you a second. Say you're selling widgets. Now, I don't know what a widget is. I don't care what a widget is. But you're selling widgets. And you sell 10 of them. And they're $5 each. How much money will be in your cash register at the end of that day? What? Good, 50. How'd you get it? 10, the number of units you sold, times 5, the cost. Well, X is the number of units sold. So what do you think the 47 represents? Yeah, 47 is the selling price. That's what they sold it for. Are you with me? Now here's the deal. You don't really need to know this information, but it's a very good idea for you to understand what that represents. Because they were nice to you. They gave you these two functions. But I guarantee you, in the next problem we do, they ain't giving you these functions. So you need to know what these numbers mean. Got it? Okay. Now let's look at the cost function. The manufacturing facility, right, where all these widgets are made. This $10,000 represents something. And this 10,000, and yes it is dollars, represents what's known as a fixed cost. Well, in the manufacturing world, the fixed cost is bills that they have to pay every month that never change. In other words, their dollar amounts never change. Like the mortgage they need to pay or the rent they need to pay every month, right? That's going to be the same every month, right? The light bill, right? The light bill, the lights are going to be on the same amount of hours every day, the same number of days. Okay, let's look at that last problem. We're talking about abstract office supplies, and they're talking about introducing, what, a new computer desk next year? Okay, so let's go pick it apart from punctuation to punctuation and see what information it gives us. So the Planning Department of Abstract Office Supplies has been asked to determine whether the company should introduce a new computer desk next year. The department estimates that Any information in that punctuation from we start to that first period? Yeah, no, nothing. It's fluff. It makes it sound good, right? Good part of the story. All right. So let's pick it up from the next punctuation to the next punctuation and see what information it gives us, if any. The department estimates that $12,000 of new manufacturing equipment will need to be purchased and that the cost of constructing each desk will be $100. Okay, any information? Yeah, that $12,000. So, What do you think that $12 represents? Yeah, that's a fixed cost, isn't it? Because they're going to have to buy $12,000, aren't they? All right, or they're going to have to spend $12,000. It's a set amount. It's a fixed cost. So we have a fixed cost of $12,000, right? And yes, this is in money. But they also told us what else? The cost of constructing each desk is $100. What do you think that means? Yeah, that's the varying cost, isn't it? Because it's constructing each desk. Right now it's $100, right? So, and in money, dollars again. So the varying cost, right, or the variable cost, and it's per unit, isn't it, is $100. With me? Okay. And then it says the department also estimates that the revenue from each desk will be $400. Yeah, revenue, right? The revenue, you know, so what does that mean? What's that $400 actually represent? Good. I heard some of you say it, so I'm going to write it. That's your selling price. And it's per unit. And it's $400, isn't it? And they want to know, right? Okay. And so here's the deal. Eventually, they're going to ask us how many desks would they need to make and sell to break even. So do I know the number of desks? Nope. I'm going to call it D for the number of desks. Okay. So the first question it asks me is to give them the revenue price or the revenue function. Well, the revenue function comes from the selling price. So my revenue function, R of D, revenue at number of desks, will be, good, 400 times D. Because I'm selling each desk for $400, aren't I? Make sense? Another question they're going to ask us is the cost function. Well, if you remember from the last problem, the cost function, the cost at D desks, is going to be the fixed cost, and then added to it is the cost per, the variable cost per, in this case, desk. Cool? All right. And now I want to break even. This company wants to break even. How many desks would they need to sell to break even based upon this cost and this revenue function? So, that's right. This is where the revenue equals the cost. Cool? Okay. Easy enough to solve. Move the 100 over. So we have 300D equals 12,000. Divide both sides by 300 and you get, well, I got 40. Did you get 40? Good, 40 desks, right? Of course, I'm going to do my double checking. Why? Because I've been on the board a long time and I want to make certain that we got everything straight. Good. Yay. This problem was easier to set up when you understood the last problem when I explained those numbers, wasn't it? It was easier to set up the cost function and the revenue function, wasn't it? Good. So, we are finally at the end of this particular lecture. All these lovely stories that we have gone over, there's been a variety of them. My recommendation is go back to the videos and rewind and stop at whatever problem you need a refresher on that you're like, you know, I need to look at that one again. Go for it. That's the advantage of a video. And I'll catch you guys on the flip side.